At the European Space Agency's Technical and Research Centre in the Netherlands, project scientist Goran Pilbrat can now admire his spacecraft, the Herschel Space Observatory, to which engineers are putting the final touches. Herschel will be the largest telescope ever launched, with a 3.5-metre main mirror seen covered here at the summit of the satellite to avoid any contamination. Its advanced detectors will gather invisible radiation at far infrared wavelengths, allowing scientists to learn more about the coldest regions of the universe to better understand how stars and galaxies formed and how the structure of the universe has changed. Herschel has a partner on its voyage up into space, another telescope, also in its final phase of preparation and pre-launch testing, seen here at the Centre Spatial de Liège in Belgium. Likewise, its main mirror is also under wraps. Planck will look even further away from the visible spectrum than infrared rays. Its goal is to map out a picture of the earliest days of the universe as it was 14 billion years ago. Remnants of light first released after the Big Bang still exist in the form of microwaves. Planck will be the most sophisticated spacecraft to chart this cosmic microwave background. In the spring of next year, Herschel and Planck will be paired under the fairing of an Ariane 5 launcher to be deployed one by one in the same region of space.
They fly to exactly the same place, not exactly the same place, but to a similar orbit around the Lagrangian point behind the Earth. So they go far behind the Earth, about 1.5 million kilometers away from the Earth, but they surround the same point. So it made just sense to fly them together.
Their destination, the L2 Lagrange point, is situated opposite the Sun, about 4 to 5 times further from Earth than the Moon, a perfect vantage point sheltered from the heat of the Sun. Herschel will follow commands from Earth, focusing very precisely on objects both within our galaxy and outside it, as far as 10,000 million light-years away. Because it sees far infrared radiation, it will be able to peer through clouds of gas and dust, revealing stars as they form.
A colleague of mine made a joke once, and he said, look, okay, so normal stars like the Sun, they are like the grown-ups, if we make the analogy with people. Now we are looking, when you see stars forming in the clouds, we're looking for the children. And then I said, well, with Herschel, we are looking so far into the cloud, we're looking at so early phases in the stellar formation, we're actually looking for the children who are not born yet.
Unlike Herschel, Planck will not look at specific objects. Instead, it will rotate continuously, scanning all of space to build up a complete sky map of microwave radiation, the fossil evidence of the first matter after the Big Bang.
As time goes by, the satellite essentially moves in an orbit around the Sun. And so this big circle that it sweeps across the sky is also sweeping itself across the sky. After about 6 months, it will have covered the whole sky. And this light carries a very clear image of the structure of matter at that time.
This pair of space observatories constitutes one of the European Space Agency's most ambitious missions. Excitement increases as both spacecraft approach the day that they will be shipped to the European spaceport in French Guiana. And scientists around the world eagerly look forward to the moment next year when Herschel and Planck will be opening new windows on the universe, allowing them to view its splendors and structure in a different light.
Ta-da.
And it will then truly be a moment to celebrate the latest advances in European space science.